Next, I'd like to talk to you about resistors in parallel. Here I have a circuit diagram where I have two light globes in parallel with one another. And it turns out that with resistors in parallel, the voltage source will send current into the system, and it'll split. Part of it will go through one light globe and part will go through another, and then get together again and go back around through the circuit. To talk about that, let's begin with just a single light globe, and then we'll throw in the second light globe in parallel. Let me turn the voltage up all the way, and we see with the maximum voltage of a little over 100 volts, we have a current of just about 1/2 ampere, 0.49 amperes, and the light globe operates with a power rating of 60 watts. Now, let's turn the power off here for just a minute, and I'll connect this other light globe in the circuit. Make a connection here and here. And what I'm doing effectively is I'm going from this circuit to this circuit. Or I'm taking this circuit with just a single light globe and adding one more light globe in parallel. Now, when we turn the power back on at the same voltage we had before, we get what we would expect if we think about it carefully. That is, the voltage of the light globe, the original light globe, is the same as it was before, and therefore the brightness of the original light globe is the same as it was before. But now, in addition to one light globe, we now have two light globes. We have two pathways for the current, and therefore we have twice as much current as we would otherwise have. That means we have just about half as much resistance. And we see that the current now reads 0.99 amperes, or about 1 ampere, and that's just about twice the current that we had before. So we have about 1/2 ampere flowing through one light globe, 1/2 ampere flowing through the second light globe, for a total current of 1 ampere. And when we go to the equation for current and voltage and resistance, the voltage is the same with one light globe as it is now with two. We have the same voltage across this light globe as we have across this one. So the voltage across the bank is the same as the voltage as it was across the original light globe, but we've reduced the resistance and increased the current by going to resistors in parallel. And now let's look at the power. The power is equal to the voltage times the current. So if we look at the power across each light globe, we see that the voltage across each light globe is the same whether we have one or whether we have two, and the current through each light globe is the same whether we have one or whether we have two, and therefore the power in each light globe is the same as it was in each light globe. The power of this light globe is 60 watts, and now we also have a power in this light globe of 60 watts. So we have 60 watts here, 60 watts here, indicating we've got twice the total power, which is consistent with having twice the total current. And now we have two light globes at 60 watts apiece, so we have a total power of 120 watts. And we see that's consistent with the power equation. We have the same voltage, but we have twice as much current, therefore twice as much total power. Showing the relationship between current, voltage and resistance, and power and voltage and current.